Hello everyone. This week we'll be talking about 7.5 Law of Sine. The formula is right here. Sine A over A equal to sine B over B equal to sine C over C, where capital A, B, C are the angles of the triangle and lowercase a, b, c are the opposite side of the angles. Okay, so the law of sine can be applied in ASA or AAS type of triangles to find the missing sides, or ASS type of triangle to find missing angles. Next, let's talk about the short derivation of sine law. Doesn't matter if it's a acute oblique triangle or a obtuse oblique triangle, the derivation will be the same. So let's say H is the height for the triangle. So for either of the triangle, we know sine A is equal to opposite over hypotenuse. So that's H over B. And we know sine B is equal to H over A. So from here we know H is equal to B sine A. The second equation, H is equal to A sine B. Both H are the height for this triangle, so we know they must equal to each other. So B sine A must equal to A sine B. Now if we divide both sides by A and B, we'll get sine A over A is equal to sine B over B. And we can do the same for sine C as well, just drawing a different height. So you can draw a height from here to here, and you'll be able to find sine C. So using this derivation, we know we can get a conclusion. Sine A over A equal to sine B over B, and that's equal to sine C over C. Using the sine law, it's very easy for us to find the sides or the angles. We don't have to do it like what we did in the previous video from last week. We can just apply the sine law, plug the number into the equation, and find the missing value. So here we have a very basic example. Let's do this one together. Well, let's see which type of triangle this is. So we have the angle, we have this angle, and we have the side that's connecting the two angles. So this question will be ASA, angle side angle. We know for angle side angle questions, we can use our sine law. So let's use it. Let's say this is A, this is B, this is C. So sine A over A is equal to sine B over B is equal to sine C over C. Let's see what we know first. We know we're looking for x, which is the A here, and we know what capital A is equal to. We know what the angle is equal to. So we have to use this one for sure. Sine 33 degrees over little a, which is the x, the missing value we want to find, and sine b over b. We know what b is. B is this number, 4. But do we know what b is? Well, it doesn't say in the question here, but can we find it? Of course, we can find b. B we know is equal to 180 minus 33 minus 38, which is equal to 109 degrees. We know capital B, we know little b. We can use this one. Sine 109 degrees over 4. So we have an equation here with one missing value, one unknown. We can use cross multiply to find the answer. 4 sine 33 equal to x sine 109 degrees. So x is equal to 4 sine 33 degrees over sine 109 degrees. And so x is equal to 2.304. And since in this question, the side is 4 kilometers, so our answer must include the unit as well. Now let's talk about ambiguous cases. That is when you are given a ASS triangle. So there are 6 cases. We are going to analyze them one by one. Case 1 will be when side A is less than the height. So if you look at this triangle on the right side here, side A is this side. Okay? If side A is less than h, then you can see that you don't really form a triangle. Side B, side C, and side A, these 3 sides, they don't form a triangle because side A is too short. Okay, so possible triangle, 0. Okay, case 2, when the side A is equal to h. When side A is equal to h, then it's really hard to make them equal here, but just assume that they're equal. Side B, side C, and side A, they form a triangle, which is a right angle triangle here, this one, where angle A is 50 degrees, side B is 3.29, and A is 2.52. So the question will ask you to find angle B. Find angle B. To find angle B, we'll need to use sine law again. So that's sine A over A. Sine A is 50 degrees over A is 2.52 equal to sine B. Sine B, we wanted to find B, so we just write B in there. Sine B over little b, 3.29. And here you can use cross multiply again to find sine B, and then use shift sign or arc sign to find angle B. We've done that before. I'm not going to do it with you guys right now. Let's move on to the next case. Case 3 is when A is greater or equal to B. In this triangle here, B is equal to 3.27. So if A is greater than that, then we'll have how many triangles? We'll have only one triangle, right? So something like that. If A is equal to B, something like that, you will have a isosceles triangle. Okay, so you'll get either an isosceles triangle or a scalene triangle. So there is one possible triangle. So in this case, the example will be given angle A is 50 degrees. Side A is equal to 5.59 and side B is equal to 3.27. The question will ask you to find angle B. So how do we write the equation? To find angle B, for sure we'll need sine B. The sine B over the opposite, which is 3.27, will be equal to, we know angle A, so will equal to sine A, which is 50 degrees, over little a, 5.59. So again, you'll be solving that using the cross multiply, and find sine B first, and then find angle B using arc sine. Now, case 4 is our ambiguous case. Case 4 is when the side length of A is between H and B. So in our example here, the H is 2.5 and B is 3.27. So let's make our A equal to 3. So something like that. So if A is equal to 3, then we'll have a triangle that looks like this. Okay? But if you think about it, A equal to 3 is not only this triangle. It could also be this one. 3 is almost there. Yeah, close enough. So you could also have a triangle that looks like this, right? So if you put them together, you'll have a triangle that looks like either that or that, where side A are both the same. Side A are the same. They equal to each other. So A, C, and B. What's special about these two triangles? There is one thing that is special. Because side A and side A, because these two sides are the same, so we know that this angle and this angle must be the same. Okay? If these two angles are the same, then this blue angle here will be 180 minus the red angle. So the possible triangles in this case, we have two. One big one and one small one. An example for case 4 will look like this. Angle A equal to 50 degrees, side A equal to 3, and side B equal to 3.27. And the question will ask you to find angle B. So same thing, use the sine law. Sine A over A to A is 3 equal to sine B over B, 3.27. We know that A is equal to 50, so we'll use cross multiply. 3.27 times sine 50 is equal to 3 sine B. And so to find sine B, we divide both sides by 3. So sine B is equal to 0.834988. And so angle B is equal to about 56.6 degrees. Now, 56.6 degrees is the angle B for the bigger angle. What about if I have the smaller triangle? So let's draw that again. This is A, this is C, this is B. That's the bigger angle. If we have the B here, then that will be the smaller triangle. We know that this angle is 56.6. So if we have the smaller triangle that looks like this, then what is angle B equal to? What is this angle equal to? This angle, like we talked about, will be 180 minus 56.6 degrees, which is 123.4 degrees. So since we have two triangles, we'll need to have two angles for the question. Case number 5, when A is less than or equal to B. So in our example here, B is equal to 4.07. If A is equal to B, then these two lengths will align each other, right? So you don't have a triangle, you have an angle. We can't have that. If A is shorter than B, then again, you don't form a triangle. You can't form a triangle like that. It's too short. So case 5, possible triangle, none. 0 possible triangles. Okay, what about case 6? Case 6. Case 6 is when A is greater than B. When A is greater than B, then we will have one triangle. You can't go to the other side. You can only go this side because your angle is open this way. Okay, so we'll have one triangle. Possible triangles, 1. Now, same thing, you have a question that is given angle A, given side A and side B, and asks you to find angle B. So the question will look like angle A equal to 126 degrees, side A equal to 9.55, and side B equal to 4.07, and asks you to find angle B. So since there's only one triangle, you can just use the sine law and cross multiply and find angle B. It shouldn't be too hard. Alright, so here is a summary of the 6 cases that we've talked about. In order to find out which case it belongs to, we'll need to know the H and the B. A is given, so if we know what the H and B are, we'll be able to find out how many possible triangles there are for each of the cases. And just a note that the 2 cases here are for obtuse triangles. If your triangle is acute, then consider these 4 cases. All right, let's do an example together. So the question asks you to determine the number of triangles that the data lead to. So the first question is that angle A is equal to 60 degrees, side A is equal to 10, and side B is 12. Drawing a diagram usually helps. So in this example, I'm going to draw a diagram first. So this is A, 60 degrees. This is B, this is C. So B is equal to 12 and A is equal to 10. Now, I'm not sure if this will form a triangle, so I'm not going to connect the line yet. We need to know what B and H are in order to find out how many triangles that there are. So B and A are given already. We'll need to find H, which is right here. How do we find H? We can find H using the sine ratio. We know sine 60 degrees is equal to H over 12. So H is equal to 12 times sine 60 degrees, which is about 10.39. A is equal to 10 and H is 10.39, so A is less than H. B is equal to 12, so A is less than B as well. Now let's check. A is less than H. Let's go back to summary. A is less than H is case 1, which is 0 possible triangles. So this one doesn't really form a triangle. A is less than B. A is less than B is for obtuse triangle, so we don't use this one. We'll only use this one. A is less than H. So from here, we know we have 0 possible triangles. Okay, question 2. Again, let's draw a diagram. A, C, and B. This is 60. This is B is 12, and A is 11. We have B, we have A, we need H. So let's write down H first. The H in this question is the same as H in part A. So we know it's 10.39. Let's compare. A is 11. 11 is greater than H. A is less than B. So let's compare it with our summary. A is greater than H is right here. We have one possible triangle. A is less than B is right here, but this one is for obtuse triangle, so we don't use this one. We'll only use the one that's greater than H. That's for the acute triangle. Okay, because our triangle is a acute triangle, so we'll only consider this one, or ignore this one. So our final answer is one triangle, one possible triangle. Once you're able to find the number of triangles possible for the given data, you'll be able to solve the oblique triangles with no problem. So the homework is right here on 7.5, questions 1 to 6 left column, and questions 7 to 12 every other questions.